You're listening to the VSL Aviation Podcast. I'm your host, Seth Blake, and this is episode 2. Thanks for listening. All right, guys, welcome back to the podcast. We've made it to episode 2. Congratulations. Today, we're going over Area of Operation 2 in our series of the Airman Certification Standards. Last episode, we spent 30 minutes talking about Area of Operation 1. Now, the reason why we're talking about Area of Operation 1 so much is that is where the majority of the oral examination goes, or comes from, when we're giving the check ride, be it the private pilot or the commercial. That Area of Operation 1 is pretty lengthy. So today, we're going to try to cover Area of Operations 2, 3, and 4. We might just cover 2 and 3. You'll see. We're going to try to keep it to that 30-minute timeline. So we're going to get started right now on Area of Operation 2. So that is pre-flight procedures. This one's going to be pretty straightforward. It starts out, our first task is a pre-flight assessment. So if you've made it this far in the check ride, congratulations, because you've made it past the oral. You're outside about to go fly. So as an examiner, we really, if you're not doing well on the oral, we're not going to proceed to the flight. At least that's kind of the policy anyway. So if you've made it to the flight, you've passed the oral, which is a good thing. So when we get out to the pre-flight, the first thing we're going to do is task A, which is the pre-flight assessment. So what you'll notice here in the next few tasks is that the knowledge and risk management, those items are going to get fewer, and you're going to see more skills be involved here. But looking at the knowledge here, you can see that you need to do your self-assessment. You need to determine if the plane is airworthy, and then you need to perform a pre-flight inspection, which is going to include you using a checklist to check each item, how to detect possible defects, associated regulations, environmental factors when it goes into pre-flight, your risk management. Hey, your kind of goes through the PAVE acronym, so your pilot, aircraft, environmental, external pressures, and then any security concerns, and then the skills. Remember, these are the things that you have to demonstrate in the check ride. So the skills for S1 and S2 is you have to be able to inspect the airplane and referencing the appropriate checklist, and then verify the airplane is in condition for safe flight and conforms to its type design. So that's a really interesting statement, because the type design, or it complies with its type certificate, is another way that I can interpret that, means that all the equipment required by the type certificate needs to be operative. A question that I like to ask on a lot of my check rides is, you go out to the airplane, let's say you're 172, and you are doing the pre-flight, and you discover that the stall warning indicator is inoperative. So if you look at 91205, or please don't use the Tomato Flames acronym, but if you use the Tomato Flames acronym, you will notice that the stall warning indicator is not listed in Tomato Flames, or more importantly, it's not listed in 91205. However, it is a required item per the Cessna 172 type certificate data sheet. So if you wanted to look that information up, if you've never heard of the TCDS, don't worry, you're not the only one. I give a lot of check rides, and a lot of people haven't heard of this. But the TCDS can be found on a database. So if you go to Google machine and you type in FAA TCDS RGL, it will pull up the FAA TCDS database. Not a very user-friendly document, but if you look under Textron, you'll find the 172 TCDS. And let me look up real quick here. I should have had this ready, but of course I didn't. The TCDS for the 172 is, drum roll, it is 3 Alpha 12. So 3 Alpha 12 is the TCDS number for the 172. Anyway, if you look on that TCDS, it'll list the stall warning horn as one of the required pieces of equipment. So that's a question that I frequently ask on my check rides. So we've done the walk around. Kind of you've had the examiner. Usually, what I'll do, I'll kind of go back here. What I do on the pre-flight is I will typically stand in the general vicinity of where you're at. I'm not going to be right there over your shoulder, breathing down your neck, watching your every move. I'm just watching kind of your general demeanor, that you're using a checklist, that you're checking the important items that are listed on the checklist. And I'll usually stand near the front of the airplane, and I'll kind of wait until you've completed the walk around, because I don't want to interrupt the walk around. That could be dangerous, right? If I start asking questions and it disrupts your flow, then you might miss some important stuff, or it kind of messes with the flow that you do on your walk around. So I'll generally kind of do a silent walk around and let you do your thing, and then I'll ask my questions. I'll usually start at the front of the airplane, and I like to ask some things that might be around the engine area. I may ask what certain belts do. I may ask, just kind of play stump the dummy, if for lack of a better term, where I point at things and say, hey, what does this thing do? Or hey, what does that do? And I'm just using that to gauge a couple things of your general knowledge about the aircraft components and where they're located, and then you're able to correlate that with where that component can be found on the walk around, and what components you can and can't check during the walk around. An example of this is a lot of people can tell me how the alternator works, right? You know that it charges your battery and works with your electrical system, but can you show me where you can check that alternator on the walk around? I'm always surprised at how many pilots know what an alternator is, they know how it works, but they don't know how to check that on the walk around, or if they can. That's just one example. So I'll ask some specific questions about the airplane during that walk around phase, and all that is kind of an extension of the oral exam that's happening during the pre-flight. So we might be covering some stuff in Area of Operation 1, kind of that systems knowledge. I may be covering some of that systems knowledge during the walk around. So that's an example of how the oral can kind of extend into the flight portion of the checkride. All right, task B is your flight deck management. So from now on, I'm just going to kind of let you hopefully are following along in the ACS and looking at the knowledge and risk management items. I'm not going to read off all of them. I'm just going to kind of discuss the high points. So flight deck management, the first thing here is one of the knowledge items is the passenger briefing requirements. That's something that fortunately most people ask, hey, would you like a passenger briefing? And normally what I'll say is, yes, please give me a passenger briefing, because that's something that I want to see that you have in your checklist, or that you have a regular briefing prepared, or briefing card, and you know how to give that. Another thing that I'll usually ask is how to use the seatbelts and exit the airplane. So I want to make sure that you know how to open the doors and explain how your passenger is going to open the door and exit the airplane. It's always surprising to me when you think about it from an outsider's perspective, that how difficult airplane doors can be to open. Some airplane, I fly a lot of Beechcraft, and the Beechcraft cabin door is surprisingly difficult to open compared to like a car door. You're used to, it's 2021. Most car doors are really easy to open. A lot of these older airplanes doors are not easy to open. I have a 1965 172, and the handle, you have to like kind of reach behind you and do a little bit of gymnastics to reach that handle and open it up. So it's not an intuitive thing to do. That's one of the things I want you to cover on your passenger briefing. Use of shoulder harnesses and seat belts. That's another big one. Sterile cockpit briefing. That would be another example. So the skills. Secure all items on the flight deck and cabin. Conduct an appropriate pre-takeoff briefing. Identifying the PIC, safety belts, shoulder harnesses, sterile cockpit, emergency procedures. And then program and manage the airplane's automation properly. So that's something that I'm looking for as far as the flight deck management task. Next up, engine starting. So we're going to position the airplane, considering structures, other aircraft, wind, safety, and then complete an appropriate checklist. Pretty straightforward. Most of the time we're not using external power to start the airplane. I don't think I've ever done that on a check ride. But if we were needing to do that, hey, that's one of the knowledge areas. Propeller safety, obviously. Hey, are you yelling clear prop? Are you visually checking to make sure that it's clear for you to start? Pretty easy task there. D, taxiing. Now, this is an interesting one. It's actually led to a couple of disapprovals because people just aren't paying attention when they're taxiing. So before we even talk about the taxiing phase, just my thought process, and the airlines and the military, their thought process on taxiing is that it's a critical phase of flight. So you need to treat taxiing just like you treat flying from the final approach fix inbound, or flying the base to final turn in the pattern. It is a critical phase of flight, and I'm always surprised at how many pilots are bending metal while taxiing because they just aren't paying attention. And it's really critical when you're single pilot, so you're not in a crewed airplane. And in a crewed airplane, we'll have a pilot taxiing, and he's the pilot flying effectively. He or she's over there taxiing the airplane, and all of their focus is on not hitting anything, keeping on the taxiway, obeying all the hold short lines, and all the things related to taxiing. The pilot monitoring is free to make radio calls and maybe plug in some stuff in the GPS, but they also need to be heads up, scanning for other traffic and possible obstructions or anything. So at no time should a single pilot be trying to taxi and mess with the radio or mess with the GPS or run checklists. Your entire focus needs to be on taxiing the airplane. So make sure when you're taxiing, you're paying attention and not trying to, impress me by your skills of multitasking and being able to work ahead and program the GPS. That's a really quick way for me to maybe start throwing some spears. Maybe I might ask some critical questions like, what should we be doing while we're taxiing? As that may be a way that I kind of hint at maybe you shouldn't be doing whatever you're doing right now while you're taxiing. So first of all, receive and correctly read back clearances if applicable. Use an airport diagram. That's a big one. If you've got ForeFlight, which again, I'm a huge proponent of ForeFlight, have the ForeFlight taxi diagram pulled up and ready to reference. More importantly, pointed out to me in the briefing before we even start moving, hey, here's where I'm going to taxi this airplane. I'm going to come out here, I'm going to make a left on Alpha and hold short of the runway. If it's something simple, then it's not going to take that long, and leave that taxi diagram out, because that shows me that you have good habit patterns, because this check ride might be being done at a small non-towered field in the middle of nowhere, but I'm not signing a certificate that says, hey, you're a pilot cleared to fly at non-towered airplane or airports in the middle of nowhere. I'm signing a certificate that would allow you to immediately take off and fly to Addison or fly to LaGuardia. And if I don't see the habit patterns that would help you be successful in those areas, then I'm going to start questioning your ability to be ready for that certificate. So make sure, use the taxi diagram. All right, position the flight controls into the wind. That's a big one. A lot of tail dragger pilots are really good about doing that, of positioning the flight controls into the wind. A lot of Cessna drivers, maybe not so much. So make sure you're thinking about that and positioning those into the wind. Complete a checklist. Okay, yeah, definitely do the checklist. Perform a brake check immediately after the airplane begins moving. This is very black and white, folks. Skill 5 says, perform a brake check immediately after the airplane begins moving. There's not a lot of wiggle room for me as a DPE. I have had to issue disapprovals for this. If you just pull out of chocks and start taxiing, that's the first place where you could maybe get a disapproval while the plane's under movement, because you just didn't perform a brake check. Perform a brake check immediately after you start moving. Now, if my position, the position that I'm sitting in, sometimes it's the left seat, sometimes it's the right seat, sometimes it's the back or the front, but if wherever I'm located, if once you come to a stop, you can say, hey sir, would you like to check your brakes? And I might say, sure, I'll check my brakes. If I don't have brakes, I'll say, yeah, I don't have brakes. If I have a hand brake, maybe I'll check my hand brake. But at that time, usually I'll check my brakes as well to make sure we both have brakes, or all the brakes on the plane are working. Or if they're just available on the left, then that's fine. All right. Maintain positive control of the airplane during ground operations. Yeah, obviously. Maintain control of the airplane and don't use excessive speed. If you think you're going too fast, you're probably going too fast. Okay? I'm never going to say on a check ride, hey, do you think you could speed things up over there? I'm never going to say that. As a DPE, I'm never going to say that. So you don't have to be, ridiculously slow. But if you think you're going too fast, you're probably going too fast. There's no reason to get in a hurry here. Comply with markings and ATC instructions, obviously, and then position the airplane properly relative to hold short lines or hold lines. So kind of the obvious there. So enough on taxiing. Let's go to taxiing and sailing. We're not going to cover this unless we're in a seaplane, and we're not covering seaplane check rides right now. We're just covering straight kind of private pilot stuff. All right, before takeoff checklist. So we have some knowledge and risk management items listed there, as always. You can see here we're kind of an even split. We have just as many knowledge, risk management, and skills. You're going to start to see this change here shortly, where the skills are going to get longer and the knowledge and risk management is going to get shorter. So your pre-takeoff items, detecting malfunctions, a couple of the knowledge items, risk management, maybe wake turbulence, power plant failure during takeoff, other malfunctions. I expect that usually to be covered in the takeoff briefing. So I want to hear from you, hey, what are we going to do? Should we experience any type of uncommanded maneuver, either a left and right, like a blown tire, or any uncommanded loss of power? What are we going to do? And then that answer should change based on altitude. Below a certain altitude, we're probably just going straight ahead. Above a certain altitude, we might be making a turn back to the airport or making a turn left or right. And I do expect to have you to have some sort of, or the applicant to have some sort of knowledge of the general area to know, right off the end of the runway is a big, 5-story building and a bunch of wires. So even if I'm at a low altitude, I'm going to make a gentle, 15-degree bank turn to the left or right to avoid that building or that obstruction. All right, review takeoff performance, complete appropriate checklist, position the airplane considering other aircraft and vessels, divide attention inside and outside, and verify engine parameters in your airplane and your configuration are suitable. So those are the skills, the 5 skills for before takeoff check that I'm looking for. All right, communication, light gun signals. We're into area of operation 3, and this is task A, communications, light gun signals, runway lighting systems. So some of this stuff we might have covered in the oral. Some of this we might covered during your takeoff briefing. But again, down to the skills, we have 3 skills: appropriate frequencies, standard phraseology, and then acknowledging radio communications and complying with instructions. So I'm expecting to hear standard phraseology, that you're using the correct frequency, and that you acknowledge radio communications and comply with instructions. If we're at a non-towered field, you may not have any instructions to comply with, but you definitely do have standard phraseology and communications you should be using. So now's not the time to try some non-standard phraseology on your check ride. So relatively straightforward on the communications, pretty easy. All right, B, traffic patterns. We're just going to talk about the skills. You can see the knowledge and risk management. Identify and interpret the runway markings. Comply with recommended traffic pattern procedures. Correct for wind drift. Maintain orientation to the runway. Maintain traffic pattern altitude plus or minus 100 feet. And appropriate airspeed plus or minus 10 knots. And then maintain situational awareness and proper spacing from other traffic in the pattern. So those are the 6 skills that we're going to do for traffic pattern. Now this is kind of the first example in the ACS where this isn't just a one and done. Maybe not the first example. There's other things where just because I evaluate it once doesn't mean I'm not going to evaluate it anymore. So in a private pilot, for instance, we're doing, probably at least 4 traffic patterns, maybe more. And so each one of those traffic patterns, I'm using Area of Operation 3, Task B, to evaluate that traffic pattern. So standard traffic pattern procedures, again, it's your references are up at the top there. It should probably have a reference for the advisory circular that was recently come out. I'd have to look that up. I'll put it on the show notes. I don't want to pause right now. But there is a recent advisory circular came out about 2 years ago about traffic pattern entry. That would be a good reference for you to have here, but especially at non-towered fields. But make sure you're making the standard phraseology calls and entering standard traffic patterns. So, if we're approaching the runway and the shortest way to land would be to enter a right base, unless there's right traffic, or a right base entry is not an approved method. You can do straight in, you can do a midfield downwind, you can do a teardrop entry, you can overfly midfield and enter a downwind. Don't be making up pattern entries. This isn't the time to do that on a check ride, because if you do it on a check ride, what I have to assume is that it's a habit pattern for you, and that's not the proper way, and there might be a gap in your training that needs to be corrected. So maybe you're not ready for the certificate, you need some additional training. So use standard pattern entries. All right, we made it all the way to Area of Operation 4. That's where I was hoping to be. Let's check our time here, 21 minutes. I think I've got enough time to go through. So this is what I was talking about before, where our skills, now we got 15 skills on Task A, Area of Operation 4, which is your takeoffs and landings. So our normal takeoff and climb includes 15 skills. So we can see the knowledge area, pretty small. Risk management area, decent size, right? There's a lot of risk management to take into account for takeoff. And then our skills, we got 15. I'm not going to read through all of these. Again, if you're watching on YouTube, you're seeing me pull it up here. If you're listening on the podcast, hopefully you've got your ACS pulled out and are listening, or you can come back when you're. I know a lot of people, throw their earbuds in and going for a run or whatnot, but take my word for it. Looking on the ACS, we've got skills 1 through 15. So as we get to the plane, that makes sense, right? Because we're flying the airplane now. It's a lot more of a skills game than it is a head game or knowledge area. All right, so we're using checklists. We're making radio calls. We're verifying runways. We're positioning for wind. Let's look at our rotate aircraft at recommended airspeed, accelerate to VY. Establish a pitch attitude to the recommended speeds, plus 10 minus 5 knots. Configure the airplane, maintain VY, plus 10 minus 5 to a safe maneuvering altitude. Maintain directional control and wind drift correction, and then comply with noise abatement procedures. Just a few of the skills that you're going to do on just a normal takeoff. All right, next up we have the normal approach and landing. We've got 12 skills listed here. I'm going to stick with kind of the objective ones, because these are the areas where they seem to be really black and white. So, and they are, right? So skill 7 is maintain manufacturer's published airspeed, or in its absence, not more than 1.3 VSO plus 10 minus 5 knots with a gust factor applied. So let's kind of chew on that skill 7 just a little bit. Not all airplanes, especially the older single engine stuff, have approach speeds published. So what we're doing is we're finding the power off stall speed, we're multiplying that by 1.3, and we're coming up with an approach speed based off of that. That's a real common way. Approach speeds and basically all useful speeds for the landing environment or the landing phase are calculated. We're doing a 1.23, 1.3, somewhere in there, times the VSO, plus 10 minus 5, and we're adding a gust factor, which is typically the so if there's a gust factor correction, if it's gusting 5 knots, I'm going to add 5 knots. If it's gusting 10 knots, I'm going to add 10 knots. If it's gusting over 10 knots, I'm just going to add a maximum of 10 knots, right? Because there comes a point of kind of reduced, how do I say that? It actually hurts us more to fly a faster speed at some point, because now we're not validating our landing distance. We're flying too fast, and we're going to have an unstable approach. So we're only going to add a gust factor up to about 10. Those are all rules of thumb. The Airplane Flying Handbook talks about this, or your manufacturer's POH will actually suggest what you do in the case of gust factors go. But that's how I'm going to see that you're calculating your approach speeds there. So let's say you are flying the approach and your approach speed is 70, and we see an airspeed of 85. Does that mean you failed the check ride? Does that mean that I have to fail you as an examiner? Well, the answer is it kind of depends. So for that, we're going to pause right here, and we're going to go to the Appendix section of the ACS, where we have this clear black and white speed, right? So plus 10. So we're flying 70 knots. Plus 10 would be 80, but we fly 85. So did we fail? Well, under Appendix 5, which is the roles and responsibilities, it defines unsatisfactory performance. So one of our unsatisfactory performance has these bullet points here. So any action or lack of action by the applicant that requires corrective intervention by the evaluator to maintain safety of flight. We'll probably fly in 85 knots. I'm not going to see that as a safety of flight issue in most cases, so I'm not going to jump in on the controls there. Failure to use proper visual or effective visual scanning techniques before and while performing maneuvers. Well, if your head is outside and you're not just locked onto the instruments during this base to final turn and you fly 85 knots, that's probably not a factor. So we wouldn't have an unsatisfactory performance because of that. Consistently exceeding tolerances stated in the skill element of the task. So the FAA understands that words matter, maybe more than most agencies. So saying consistently exceeding tolerances, well, that's important, because they didn't say just exceeding tolerances. They say consistently exceeding tolerances. Consistency is kind of a subjective word. What is consistently? 9 out of 10 times? 6 out of 10 times? I don't know. I don't know. It doesn't really define consistently anywhere. And then failure to take prompt corrective action when tolerances are exceeded. So again, words matter. So it's almost saying, the in between the lines of those two statements is saying that, hey, we kind of expect you to exceed tolerances, but as long as you're making a prompt corrective action, then that's not grounds for unsatisfactory performance. And unless you're consistently exceeding tolerances, that's not grounds for unsatisfactory performance. So the I guess condensed point of those two bullet items is that perfection is not the standard. So going back to our area of operation that we were on for our takeoff, let's see, we were in 4, and our example was flying 85 knots. Oh, didn't want that. You can find area takeoff right here, normal approach and landing. So we're doing a normal approach. We're supposed to be flying 70 knots, and we fly 85 knots. So that's 5 knots over what the ACS says. So we've exceeded the tolerance specified. So it depends on if that's worthy of a disapproval. If you consistently, so for every single approach, if you're always flying at 85, well, that's consistent, and that's grounds for disapproval. If you just did it once or for a few seconds, even a couple of times, a few seconds during multiple approaches, you got up to 85 and the winds were gusty, yeah, that's not worthy of a disapproval, I don't think. all things being equal, you're probably going to pass for that condition, because I'm going to see that as a momentary deviation that you recognized and corrected for. So even though the skill elements in the takeoffs and landings, all the performance maneuvers are very exact, and they seem to be black and white, and they are black and white, later on the ACS says that that's not necessarily grounds for disapproval if you have a momentary deviation from those and it's not consistent. So think those two things. Momentary deviations are okay, and they're kind of expected. I mean, even myself, I've got thousands of hours and I fly all the time. I'm going to momentarily exceed these tight, rather tight tolerances. Now, if we start exceeding bigger numbers like V&E, momentary deviation of V&E, it's a different story. Some other things went wrong for us to even get in that flight regime. So that's probably not going to be seen as a momentary deviation. That's an exceedance of the aircraft's safety envelope. So that would be more of a safety of flight issue. But if it's just 5 knots over your approach speed, not a big deal. Touchdown at the proper pitch attitude within 400 feet beyond or on the specified point. So for all of your landings, let me do you a favor right now. For every single landing you're doing, pick a touchdown point you want and make sure you either hit that touchdown point or you hit within 200 feet just beyond that touchdown point. Hold yourself to that standard. A good way is if your airport is marked with 1,000-foot markings or instrument aim point markings. Try to make sure you're leaving black marks on those 1,000-foot markers every single landing you're doing. If that's your goal, when you come to the check ride, you're going to be successful. No matter if you're doing the private pilot, commercial, or instrument, you're going to be able to hit a touchdown point. That 200-foot zone, that should be what every pilot's aiming for. And it's -0 plus 200. In this case, it's -0 plus 400. So, we hopefully, as kids, you probably all played the floor is lava game, right? So the floor is the runway in front of the 1,000-foot markers is lava. You cannot touch down there. As long as you touch down after that on your touchdown point, within 200 feet, you're going to be golden. And if you're holding yourself to those standards from day one of your pilot training, that's going to help you so much in all of these check rides. All right, execute a timely go-around if the approach cannot be made within tolerances specified above, or if any other condition may result in an unsafe approach or landing. I'm going to say something maybe a little controversial amongst the DPE community, especially DPEs that I've talked to. But we train this way in the Air Force, and in real world flying, this is the fact. Go-arounds are free. You can always go around. There is a very small window of circumstances where go-arounds are not doable, and I kind of hold that in a different realm than I do normal approaches and landings. But on a normal approach and landing, go-arounds are free. You can go around. And going around during a check ride should not be a big deal, and it is definitely not an automatic failure. Now, landing short of your desired touchdown point, that is grounds for failure. That's one of those black and white items. It's hard to say landing short is a momentary deviation or consistent. Like, it's hard to fit that into one of those gray areas. Because it's a done deal. If it was a real world event, you just landed short of your landing surface, which means you landed off the airport, which means you probably broke something. So don't land short. You can land long. Now, you can land long in that, let's say you float past your 400-foot zone, and you feel like, oh yeah, that's definitely 400 feet. This is kind of a gross float here. And you decide to go around. And you go around, and either at the time you decide to go around or shortly thereafter the wheels touch the runway. Not an automatic failure in my book, because in the real world, you floated past your touchdown zone and you made the right decision. You decided to go around, because in a real short field landing scenario, And we'll get to short field here in a second. But in a real short field landing scenario, if you float past your landing zone, you're going to go around because you don't have enough runway to stop, but you're at, by definition, you're at a flying airspeed. If you just touch down, you're at flying airspeed. So just add the power, go around, and come back and try again. That's all that I want you to do. So if you land long, not a big deal. Landing short is a big deal. So don't land short on your check ride. All right, next here we have soft field takeoff and climb. So soft field here. Here are our objective skills. We have 14 skills for the soft field. You notice that the risk management for all of the takeoffs and landings are very similar. I think some of them are exact replicas of one another. Notice that all of them, though, have the rejected takeoff for a risk management, and all of the landings have planning for a go-around or rejected landing. So in my book, that means that if the FAA is asking me to assess your risk management abilities for ability to reject the takeoff or reject the landing and do a go-around, then that means the rejected takeoffs and go-arounds are free. You can do as many as you want because they're on every single one of the tasks in Area of Operation 4. So back to our soft field takeoff and climb. We are going to establish and maintain a pitch attitude that will transfer weight from the wheels to the wings as rapidly as possible, lift off at the lowest possible airspeed, and remain in ground effect. That's really important. That's a real common error that I see on the soft field is we do the first part, we lift off at the lowest possible airspeed, but then we keep climbing. And as soon as you climb out of that ground effect, you lose ground effect and bad things start to happen. You can enter a stall and you can rapidly sink back to the runway or even drop a wing because you're not stalling coordinated and have an accident there. So you definitely want to keep in ground effect, accelerate to VX, VY as appropriate, and then climb out. And configure the airplane after a positive rate of climb has been verified. So that's another one, the positive rate. What I'm looking for is a positive VSI and the altimeter trending higher. I need to see both of those things before we actually have a positive rate. Maintain directional control, comply with noise abatement. Yep, got it. Soft field landing. Again, we're looking at that 1.3 times VSO if it's not published. We're making smooth inputs. We're going to touch down appropriate pitch with minimum sink rate, no side drift, and with the airplane's longitudinal axis aligned with the center of the runway. If I had $1 for every time I say line the airplane's longitudinal axis up with the runway, I would have a lot of dollars. I can't provide instruction during the check ride. So this is when I'm doing instructional duties, both in the military and in the civilian world. I see this all the time where you just have to have situational awareness of where the longitudinal axis of the plane is. And it's really your sight picture. If you're not looking through the front of the windscreen down the end of the runway, then more than likely you're doing something wrong when you're flaring, right? You should be looking down at the end of the runway. It should be going straight in front of you out the windscreen. If you're looking out the left side of the windscreen, then that means you've got a pretty good right to left crosswind, and you're weather vaning, and you're going to land in a side-loaded configuration, and that's going to be really hard on your landing gear, and in some airplanes it might even lead to an accident, a ground loop. If you're in a tail dragger, it might lead to a PIO. If you're in a tricycle gear configuration, it may lead to a gear failure if it's at a high enough angle of crab. But don't land in a crab. That's the main thing. Don't land in a crab. That's what that means. And it's really common for this to happen in the soft field landing because we're at a relatively high angle of attack. We're at a slow airspeed, and the wind has more of effect on the airplane, right? You're not moving the airplane through the air nearly as fast, and the wind starts to have more of a weather vaning effect. And so you might even need to increase your crosswind controls that were working for you back there on final but are no longer enough when you're in the flare. You might need to add that in. That's a real common error that I see, is in the soft field we land slightly side-loaded without that longitudinal axis of the airplane lined up. Execute a timely go-around if you can't make it within those tolerances. Again, go-arounds are free on the soft field. Short field takeoff, maximum performance climb. So short field takeoff, pretty straightforward. Most aircraft checklists are going to have this defined in there. Let's see, we are having a 50-foot obstacle is our simulated obstacle. We're applying brakes while setting engine power to achieve maximum performance. So we're holding the brakes. We're doing that static takeoff power push, releasing the brakes, accelerating out to your rotate, VX, clear the obstacle, VY. Big picture, that's what we're looking for. On the short field approach and landing, here's where the tolerances get a little bit tighter for the touchdown point. We have the touchdown at appropriate pitch attitude within 200 feet beyond or on the specified point, so 200 feet. So that's what I'm saying. If you're practicing 200 from day one of your training, that's going to set you up really well for all of your private pilot training, your instrument training, and on into your commercial and ATP. We want to be able to hit that 200-foot zone consistently. Perfect practice makes perfect. Not just practice makes perfect. Perfect practice makes perfect. So aim for that 200-foot zone. Do not land short. If you land long, what do? You go around. As easy as that. If you land long, go around. And remember, go-arounds are free on the short field landing, even after you touch down in my book, because it says for if the approach cannot be made within the tolerances specified above. Well, one of the one directly above that, the 200 feet on or beyond. So if you're beyond, go around. That's fine. In a real-world short field landing, that's what I'm going to do. So go-arounds are free. Confined area takeoff, not doing it. Confined area approach, not doing it. Glassy water takeoff, not doing it. Glassy water approach, we're not doing it. Rough water, forward slip to landing. Here we go. Task M, forward slip to landing. This might be combined with one of the other approaches, like the normal approach and landing. I might intentionally set you up in a condition where you're kind of high and you need to forward slip in order to get back on normal glide path. A lot of times, honestly, this happens in the normal course of the flight. One of the approaches, generally you're going to be a little high and you're going to have to use a forward slip to land. If you want to work ahead kind of on your check ride and maybe help this out a little bit, is you could tell me as an examiner, hey, on this normal approach, I'm going to fly it a little high so I can show you a forward slip to landing. I would totally accept that as an examiner. If you're taking control, that's what I expect you to do as a pilot in command anyway, is if you're taking control and you're telling me how you're going to accomplish an item that's required by the ACS, that tells me two things. That tells me, one, you know how to be an aircraft commander or a pilot in command, and two, you are familiar enough with the ACS to know what you're going to have to do. So I think that's great if you're going to do that. This is the normal one. We need to touch down within 400 feet or beyond. So this, I guess, fits well. This dovetails well into the normal landing, doing a normal landing after you do a forward slip to correct for that. So as necessary, correlate crosswind direction with forward slip and transition to the side slip before touchdown. I bring up that because that's the most common one, is if I have a right to left crosswind. So I'm crabbing to the right? The wind's coming from my right, it's hitting my vertical stabilizer, and it's causing the tail to move over to the left, which points my nose to the right. A lot of right-left talk going here, and this, if you're listening to the podcast, you might be a little confused, but try to visualize this with me. You're coming down on final, and you're looking out the left side of your windscreen to see the runway. So I'm looking down at the left side of my windscreen, and I want my runway to be in the middle of my windscreen. So I step on the left rudder to line that up. Okay. Now, if I need to do a forward slip right now, I'm not going to go left rudder, right wing down, because then when I recover from that side slip condition, I need to go opposite of what I'm doing to correct for the crosswind, if that makes sense. So I'm going to try to take that crosswind control and dovetail it with my forward slip to landing. So I want my forward slip to be in the same crosswind correction, not the opposite. And I see this a few times, and again, it's probably not an automatic failure. It's going to be one of those where you're going to see me writing a note over there. Unless, if you handle it correctly and you recover it and safety of flight isn't jeopardized in any way, it's probably going to be a debrief item for us. But I'm definitely going to be asking you some more questions on how to appropriately use that forward slip to landing, especially when you're dealing with a crosswind in addition to that. Go around rejected landing. All right. So not only are go-arounds free, they're required. I have to see you do a go-around / rejected landing. So make a timely decision. That's number one. I don't want to see you be Chuck Yeager and save a bad approach. I'm not saying Chuck Yeager ever did that. I have no idea, but it sounded good. So I'm not expecting for you to make some big athletic movements with the airplane to try to make a bad approach work. In fact, I'm wanting to see the opposite. I'm wanting to see you say, "Oh, this approach really isn't up to my standards. I'm going around." And if I'll sit over there quietly and I'll think, "Man, I didn't think it was that bad." I would much rather be thinking that than be sitting over there thinking, "Okay, am I going to have to grab the controls because this is turning into a rodeo?" So don't make me think about taking the controls. If it looks like it's not going to be a good approach in landing, go around. Remember, go-arounds are free. I have to see one. So if you're in a condition where you need to do a go-around, just go ahead and do it. Just do a go-around and say, "Hey, all right, I'm going around. This looks bad. I'm going to come back around and try it again." All right, we're to area of operation 5. So we covered areas 2, 3, and 4. I didn't cover all the skills. Again, this isn't just me about reading the ACS. That's not what I wanted to do with this podcast. I want to cover the high points and talk to you about the ACS and about how I view it as a examiner giving check rides. So I covered those high points. Hope it was helpful. If you've got anything to add, feel free to comment, email me. You can look up contact information on VSL.aero, AERO. You can find us on Facebook. You can find us on Instagram. You can find us on Google. You can find us anywhere. If you want to schedule a check ride with me, that would be great. I'm pretty booked up, but I'm about a month out. But if you want to talk about check ride scheduling, you can do that through the website as well. So I hope you're finding this helpful. Next episode, we're going to start up at area of operation 5 and move on from there. Still went over the 30 minutes a little bit, so sorry about that. Maybe I just need to say, hey, this is going to be a podcast. I have no idea how long it's going to be. I'll just keep it under an hour or something. But all right, that's enough jabbering. I will talk to you next time. See ya.